Hello, welcome to another pre-AMC 8 video on SaMi's YouTube channel. I'm Olivia, and let's get started. So in this addition problem, each letter stands for a different digit. And we know that t equals 7, and the letter O represents an even number. So what is the only possible value for W? Alright, so we can start writing things out just because we already know the value of t, right? So t is 7, and then we have WO plus 7WO equals RUOF. Okay, so because we have 7 plus 7 on the end in the hundreds place, when they add together, they're going to make 14, or if we're carrying a number from the sums of W, so if we're carrying a number like, let's say W was 9, and we did W plus W, 9 plus 9 is 18, then we'd carry the 1 over here in that case. So if that happened, we'd get 15. So either 7 plus 7 is 14, or we add another 1 from the carried W addition, and then we get 15. But either way, that means that no matter what, F is going to equal 1. Okay? So we have T is 7 and F is 1. The other thing we know is that O is an even number. So that means that we wouldn't carry this 1 here from the W addition, because if we did, then we'd get 7 plus 7 plus 1 is 15. We can't have 15 because O has to be even. So that means O has to be 14, because we have 7 plus 7 is 14, and we don't have any additional 1 carried over. So O then has to be 4. So rewriting that, we've got 7W4 plus 7W4 equals RU14. Okay, another thing we could keep going with is that R, right, we're doing 4 plus 4, that means R is going to be 8 here in the ones place. So now we have another thing, R equals 8. Okay, now we just need W and U. So we know W has to be less than 5, right? Because if W was 5, then we would do W plus W, 5 plus 5, and that would be 10, and then we'd carry a 1 over to the 7th place, which we already found out isn't going to happen. But if W was 4, then we could do 4 plus 4 is 8, and we wouldn't have anything to carry over. So W has to be less than 5. Okay. So what could we use that's less than 5? So we've already got 1. 1's in use, right? We already said that F is 1, so it can't be 1. And we know that O is 4, right? So W can't be 4 either. Okay, and then also we know that W can't be 0, because then we would have 0 plus 0 equals 0. Then we would have W plus W equals W. Instead, we have W plus W equals U, right? So that doesn't work because we would need W plus W equals W for W to be 0. Okay, now it's between 2 and 3. Could W be 2? Well, if we did 2, we'd have 2 plus 2 is 4. And then we would say that U is 4. The only problem with that is that we already know that O is 4, so U can't be 4 as well. So that doesn't work. That leaves us with 3. So if W is 3, then we do 3 plus 3 is 6, and then U is 6, which works. So W is 3. Okay, so the front view of the cube is going to look like this, right? That means that we've got 1 cube, and we've got 2 cubes and 3 cubes. So we have at least 3 cubes there. Okay, well, we know we're going to need more than 3 cubes, because looking at this from either side, it's either going to show us this, right, from the right side, or the same thing like this from the left side, looking at it. So that means that 3 is out. It can't be 3. What about with 4 cubes? Well, if we have 4 cubes, we could add another cube. Let's see how I could draw this so that you can see it. We could have cubes like this, and then another cube behind this one. So that would look like a cube here, a cube here, like this, a cube like this, and then a cube here, and then another cube on top. That's kind of tricky to look at. But let's see if you can picture that. So if that's the cube, we could have this being the front view. So from here is the front view. Or no, from here's the front view, and then you've got that view, and then this other side is the side view. And I know that might be a little tricky to visualize. It's a little bit confusing with these like visualization problems. But that is an example of 4 cubes being used to make the shape with the front and side view that we're looking for. So our answer is B, which is 4. Okay, Allie, Bonnie, Carlo, and Diana are going to drive together to a nearby theme park. 4 seats, driver's seat, a passenger seat, and 2 back seats. Bonnie and Carlo are the only 2 who can drive the car, so how many possible seating arrangements are there? Alright, let's draw this car. Here we've got a front seat, side seat, and then the 2 passenger seats. That doesn't really look like a car. We'll add like a window and some wheels. It kind of looks like a weird face. But let's pretend that's our car. So we know in the driver's seat, this is going to be the driver's seat because I am not British. In the driver's seat is either Bonnie or Carlo. So there's 2 people who could go in the driver's seat. Okay. What about how many people could go into the passenger seat? Well, after we've picked somebody to be in the driver's seat, either Bonnie or Carlo, there's 3 people left who need to be seated, right? So let's say we chose Carlo to be the driver. Let's say it's Carlo. Now, Allie, Bonnie, and Diana are looking for a seat, right? So there's 3 different ways for them to sit here. Okay. Now, in the back seat, there's 2 people left. So one could take the left seat and the other one could take the right seat. So out of the 2 people left, there's 2 ways they could fit into the left seat. So either, let's say we put Diana in the passenger seat, then either Allie or Bonnie go into the left seat on the back. So there's 2 ways that could happen. And then the last person who doesn't have a seat yet would have to sit in the last remaining seat. So going with that, there's 2 people who can sit in the driver's seat. And after you've picked somebody to sit in the driver's seat, there's 3 people who are left to sit in the passenger seat. And after somebody's been sitting in the passenger seat, there's 2 people left to sit in the left back seat. And then the last person has to sit in the right back seat. So that's 2 times 3 times 2 times 1, or 12 ways for them to be seated. 6 children from 2 families of 3 siblings each. So children from the same family have at least one of these characteristic in common. So we need to know which 2 children are Jim's siblings. So Jim's siblings have either brown eyes or blonde hair, right? Because that's what Jim has. And they each share one characteristic. Okay. So are there any people who have neither brown hair or blonde hair? Because if they have neither, then they can't be Jim's siblings. So right away, that eliminates Benjamin, who has blue hair and blue eyes and black hair. That eliminates Tevin, who has blue eyes and black hair. And that's it. Anybody else could be a sibling. So no Benjamin or Tevin. So that eliminates B, C, and D. All right, let's see who else. So we have Nadine and Austin. So Nadine and Austin, do they have anything in common for them to be siblings with Jim? Because if they're siblings with Jim, they're also, according to this, siblings with each other. So Nadine and Austin would need to have something in common. But they have 2 different eye colors, right? Brown and blue, and 2 different hair colors, black and blonde. So those 2 aren't siblings with each other. What about Austin and Sue? They both have blue eyes and blonde hair, so they can be siblings. And just like Jim, they have blonde hair. All 3 of them have blonde hair. So there we go. Jim's siblings are Austin and Sue. Okay, so we want to find out who's invited to Sarah's party. And we see here that Sarah's inviting her friends and all of the people who are friends with at least one of her friends. So let's see who that reaches. So we can see who's connected to Sarah. This person, this person, this person, this person, this person. And here are all the lines that are connected to Sarah. Okay? And who's connected to a line that's connected to Sarah? So we see that this friend of Sarah's is connected to this person, so they'd be invited because they're a friend of a friend. This person, they connect to the same person, so that's covered. This person's a friend of a friend. This person over here is a friend of a friend. These two are connected already. This person's a friend of a friend, and so is this person. So now these are all of the people that Sarah would invite, right? Because they're either connected to her or connected to somebody that's connected to her. So connected to her or 2 dots away, right? So how many people are left to not be invited? Well, that would be these 3 dots, these 3 people. This person over here who's a little lonely, which is unfortunate. This person and this person. So how many dots are circled? That would be D, which is 6. So we want to find how many integers between 1,000 and 2,000 have all 3 of the numbers 15, 20, and 25 as factors. Okay, so if they have 15 as a factor, right, let's see if they have 15 as a factor, we can factor these numbers to figure out what they must be divisible by, right? So basically, we want not the least common multiple of 15, 20, and 25, but all of the common multiples of 15, 20, and 25 between 1,000 and 2,000, right? So let's take a look at 15. So for a number to be divisible by 15, it needs to be divisible by 15's factors, right? So if it's divisible by 15, it's divisible by both 3 and 5. If a number is divisible by 20, it's divisible by 4 and 5. And if a number is divisible by 25, it's divisible by 5 and another 5, so 2 5s, right? So we're looking for numbers that are divisible by 3 and 4 and 5 twice. So they need to be divisible by 5 squared, right? Because if they're divisible by that, then they're divisible by 15, 20, and 25. So 5 times 5 is 25, times 3 times 4, so 25 times 12. These numbers need to be divisible by 300. So how many integers between 1,000 and 2,000 are multiples of 300? Well, we've got 1,200, add another 300, 1,500, 1,800 are all divisible by 15, 20, and 25. And then after that, we get to 2,200, which is bigger than 2,000. So we have 3 answers, answer choice C. What is the measure of the acute angle formed by the hands of a clock at 4:20 in the morning? All right, let's draw a clock. Okay, you'll have to forgive me. I am not an artist. Okay, 4:20, that's about, we've got little hand at the 4, it's about there, and also big hand at the 4. Okay, you may be like, yo, I'm pretty sure it says 0, right? Because shouldn't the big hand and the little hand both be at 4? Well, that's a start. Like, I get where that comes from, and that's a good place to start, but it's not exactly true, right? Because the little hand isn't perfectly at the 4 anymore. The little hand is on its way to the 5, right? Because it was at the 4 at 4 o'clock, and now it's moving its way to 5 o'clock, right? So the big hand's a little bit past, or the little hand's a little bit past the big hand, but the little hand is at the 4 mark. Okay? So we need to figure out how far this little hand traveled between the 4 and the 5. Well, at 4:20, there's 60 minutes in an hour, so 20 minutes into that 60-minute hour, 20 over 60, that's 1/3 of the way. So we're 1/3 of the way through the hour. So this little hand is 1/3 of the way between 4 and 5, right? Okay, so how many degrees are between the 4 and the 5? That's a good question. So we know that all numbers in the clock have the same distance between them, right? To get from the 12 to the 1 is the same distance as from the 9 to the 10, right? And there's 12 numbers on a clock and 360 degrees in a circle. So 360 divided by 12, because there's 12 numbers, is 30 degrees. So there's 30 degrees between each of the numbers. So if there's 30 degrees between the 4 and the 5, and the little hand has traveled 1/3 of that way, what's 1/3 of 30? So in other words, 30 divided by 3, right? To find a third, we divide by 3. 30 divided by 3 is 10, so there's 10 degrees between the big hand, which is at 4, and the little hand, which is 1/3 of the way to 5. Okay. We've got a trapezoid with area 164 centimeters squared. All right, so how are we going to find BC? Well, we know that we have we can see that we have some triangles to work with. They may be a little bit hidden. Let me see if I can draw them out for you. So here we've got this triangle, and over here we've got this triangle. There's some things we can see about them, right? So first of all, they both have height 8. And we can use that to solve for the base, right? Okay, so we know we have Pythagorean theorem. That's a squared plus b squared equals c squared. And that's going to apply to our triangles. So the hypotenuse squared equals 8 squared plus our bases squared. So let's start with our triangle on the left. We have 8 squared plus something squared equals 10 squared. So 64 plus something squared equals 100. What's 64? We're going to subtract 64 from both sides of the equation, and we get something squared equals 36. Okay, so what are we going to find out is 36 when it's squared? Well, if you've memorized this, that's good. If not, it's okay. But it turns out that 6 times 6 is 36, right? So the square root of 36 is 6, and that is that length. All right, what about our other triangle? We've got a side of 8 and a side of 17. We've got 8 squared plus, we'll say, x squared is 17 squared. Okay, 8 squared, 8 times 8 is 64, plus x squared equals 17 squared, which is 289. It's okay if you don't have that memorized. You could do 17 times 17 and write it out. Okay, we can subtract 64 from both sides of the equation and get x squared equals 225. So what's the square root of 225 if we want to solve for x? Well, taking the square root, it's okay if you don't have it memorized. You could do some guessing and checking. It's 15. All right. That's pretty good. So let's find the area of these triangles that we have. So we want the total area of the trapezoid, and we can help find BC by finding the area that we already can know, right? So our left triangle is 6 times 8 divided by 2, right? Base times height divided by 2. So 48 over 2. That triangle has area 24. Our right side triangle, 8 times 15 divided by 2, which is the same as 4 times 15, which has area 60. So far, we've accounted for our two triangles, which have the combined area of 60 plus 24, which is 84. Okay? And we have a total area of 164. So what we're missing is 164 minus 84, which is 80. Right? We're missing 80 for our area. And that 80 is going to come from the rectangle that we haven't accounted for yet. And that rectangle, we know, has length 8, and we just need to know its width. So 8 times width, that's going to equal 80. 8 times width. So what would width be? we can divide width by 8. 8 times width by 8. And we get width equals 10. Right? 10 times 8 would be 80. So that means BC is 10. Answer choice B. Okay, this one could be a little tricky. So we want to know which figure has a shaded region with the largest area. Okay, so let's say that these regions didn't have the white part in them, right? So that would mean that our squares for A and B would have width and length of 2, right? So without the white part taken out, this has area 4, this has area 4, and then C has area, well, we know that the diameter is 2, so that means radius 1. And remember, the area of a circle is radius squared times pi, so that would be pi is the shaded region without the white part taken out. Okay, now let's figure out what we would lose by taking out the white part. So in A, just like in C, now we've got a circle with diameter 2 and radius 1. Remember, the area of that, a circle with radius 1, is radius squared times pi. So the shaded region of the circle is the 4 minus the white circle, which is pi. And that is the shaded region in A. So 4 minus pi. All right, what about in B? Here we've got 4 identical circles, right? And each of these circles have diameter 1, right, halfway across. So they have radius 1/2. We're looking for radius squared, so 1/2 times 1/2 times pi, to be the area of each of those circles. So that's pi over 4, right? 1/4 pi, or pi over 4. And there's 4 of those circles, so we'll multiply that times 4. So pi over 4 times 4, that means that the combined white region in those 4 circles in B, that equals pi. So the shaded region of B is 4, minus the unshaded region of B, which adds up to pi. That's the shaded region with the largest area. That's the shaded region in B. Okay, what about C? How would we find the area of that square that's inside the circle? Well, this is the part that's a little bit tricky. Okay, we don't know the length of the circle, of the square, but we do know this diagonal, right? This diagonal is the same as the diameter of the circle, right? Because it goes all the way across the circle. So that diagonal has length 2, is that diagonal. So how would we find the area of the square knowing the diagonal? Well, we can use Pythagorean theorem, right? A squared plus B squared is C squared. So in this case, A squared and B squared are the same, right? Because these two sides of the triangle are the same. Or these two sides of the square are the same, right? Because it's a square. So A squared plus A squared equals 4, which is 2 squared, right? So that means 2 times A squared equals 4. Dividing both sides by 2, A squared equals 2. And then the area of that, or the A then, would be the square root of 2. Okay. So the area of that square then, with side length square root of 2, is square root of 2 times square root of 2, which is 2. So that entire area of C is pi minus 2. Okay, and we want to know the shaded region with the largest area. So what's bigger, 4 minus pi or pi minus 2? Well, let's just use 3.14 for pi. Even though it's not exact, it's close enough. So 4 minus 3.14, that's 0.86. So A has area about 0.86. Same with B, about 0.86. What about C? Pi minus 2, 3.14 minus 2, that's 1.14. which is bigger than 0.86. So the shaded region with the largest area is C, which is C. All right. We want to know where the mouse would be after the cat and the mouse would be after 247 moves. So we know that the cat, its pattern is repeating every 4 times, right? First it's going to be in the top left, then the top right, then the bottom right, then the bottom left. And then it repeats again, right? So we've got, we've got 1, 2, 3, 4. And then its 5th position, C, is the same as its 1st position. And then it keeps going in that pattern, right? And we can notice something about this. Every single time the pattern is a multiple of 4, it's going to be in the 4th position, right? So that would be the bottom left. So every 4 moves, our cat's going to be in the bottom left. Okay? So that applies not only for 12, but like 120 also. So on the 120th move, we can know because it's a multiple of 4, it's going to be in the bottom left because this pattern is repeating and it's the same every 4 moves. So 247, is that divisible by 4? Let's see. Oh, unfortunately it's not, right? There's a remainder of 3. So which one of those positions, 1, 2, 3, or 4, always have remainder 3 when divided by 4? Let's take a look. What about 2? 2 doesn't have a remainder of 2 when divided by 4. It's 3, right? 3 is a remainder 3 when divided by 4. 7 has a remainder 3 when divided by 4. So does 11, and on and on. So that means that on the 247th move, the cat is on position 3, which is here, the bottom right corner. So we want the cat to be in the bottom right corner. That eliminates answer B, answer D, and answer E. All right, what about the mouse? It's going to repeat its position after every 8 moves, right? After every 8 moves, it's doing the same thing. So we can divide 247 by 8 to figure out at what step of the pattern is the mouse at. So when you divide 247 by 8, it has a remainder of 8. Right? Remainder of 7. Sorry. So this is the position when the mouse is at position 1 with remainder 1, remainder 2, remainder 3, remainder 4, remainder 5. Then we'd get to remainder 6, remainder 7, remainder 8. So we want remainder 7. That's that point right there. Is that an option? It is. Answer choice A has the mouse in the 7th position and the cat in the 3rd position, which is what we want. All right. So we can see a ship's path from A to B to C, and we can see how it's moving in relation to X. So we want to define how far away the boat is from X at any given time. Well, let's take a look at that. So to start off, the ship is about this far away. Okay, when it's here, is it the same distance away? It is, right? Our boat is traveling in a circular path around X, so its radius relative to X is always staying the same, right? The boat is always going to be the same distance away from X in that first part all the way until it gets to point B. So in that entire time, our boat is staying the same distance away from X, right? So that means our graph A isn't correct, and our graph C isn't correct, and that's it, right? In B, we can see our graph is the same distance away from X. Okay, what about as the boat travels from B to C? Is it going to get closer or farther away from X? Well, I can see that X is the closest to the boat here at this point. right? That's the smallest distance away from x to the boat. So at point B, x is farther away than the boat would be when it's halfway between points B and C. So the boat is getting closer to x here and then gets farther away again. So we want a graph that shows the boat getting closer and then farther away. And that would be B. Notice how the curve goes down, showing the distance is decreasing, and then the curve goes up, showing that the distance is increasing again. All right, let's fill in what we know. So we know the area of square WXYZ, this square, is 25 centimeters. So what can that tell us about our side length, right? If the area of a square is 25 centimeters, the side length is the square root of that area for the square, right? So width times length, which are the same in this case. So width times itself is 25. Square root of 25 is 5, right? So the WXYZ has side length 5, and that means it has area 25. Okay? The four smaller squares have sides 1 centimeter long. So here's 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter. Same here. And then we know AB equals AC. Just make a line here. And when ABC is folded over side BC, so when ABC is folded here on this point, A coincides with O. So when it's folded, it would flip itself to look like this. And we want to know what the area of triangle ABC is in square centimeters. All right, so let's see what we can figure out about ABC. So we know that here where it's attached to, we've got some squares. This is kind of confusing. Where it's attached to, we've got some squares taking up space on a segment that has length 5. So that entire thing is length 5, but these squares are all taking up 1 centimeter, right? Which leaves the triangle, which starts here, to only get 5 minus 1, which is 3 centimeters of length, right? So ABC, draw ABC, this length for ABC is 3. Okay, what about its height? So this distance here. So we know that from here to here, that length is 2, right? Because we've got one for the square and another one from the square. So that is a length of 2. Okay, what about to the center of square WXYZ, right? Because it's going from the end to the middle. Well, to go to the middle, you need to go half of the distance, and the distance is 5. So half of 5 is 2.5. So to get from this edge to the middle, you have to travel 2.5. Okay, so that means that our square has height 2.5 plus 1 plus 1. So that's 4.5. So now we know that triangle ABC, base 3, height 4.5. Okay, and we want to know its area. So we need to find base times height divided by 2. So 4.5 times 3 over 2. 4.5 times 3 is 13.5 divided by 2. So we've got 4.5 times 3 divided by 2. 4.5 times 3 is 13.5. Dividing it by 2, that gives us 6.75. Okay, and we want it written as an improper fraction. So 6.75 is the same as 6 and 3/4. And writing that as an improper fraction is 27/4, which is answer choice C. Okay, we see on a map, a 12 centimeter length represents 72 kilometers. How many kilometers does a 17 centimeter length represent? So 12 centimeters is 72. So we want to find how many kilometers 17 represents. Okay, here's another example of cross multiplying, right? We do 17 times 72 and then divide it by 12. And there's our cross for the multiplying. So 72 times 17. That would be 1224, and then we divide it by 12. Which gives us 102. Answer choice B. How many different 4-digit numbers can be formed by arranging the 4 digits in 2004? Okay, so we're looking for 4-digit numbers, right? That means that the first digit cannot be 0, right? Because 0204, that's not a 4-digit number. That's a 3-digit number, right? It's the same as 204. So we need we need a 4-digit number that either starts with a 2 or starts with a 4. Okay, if it starts with a 2, then we need to place our 4, right? So the 2 with the 4, it could either go here, here, or here. There's 3 ways to place the 4, right? And the other 2 spots would be taken up by the zeros. So with the 2 in the thousands place, there's 3 ways to put the 4. Okay, what about with the 4 in the thousands place? Now we need to place the 2, right? Because the zeros can just go whatever place is left. So in that case, the 2 could go here, here, or here. There's 3 ways to place the 2. So we've got 2 cases, each with 3 ways to do them. 3 plus 3 makes 6 total arrangements. And we can list them out too. So 2004, 2040, 2400, or 4002, 4020, 4200. Okay,